In the last class, we discussed up to free radicals. Now we are going to discuss about electron displacement effects in organic molecule. So first let's see what is electron displacement. Electron displacement is nothing but the displacement of electron through bonded electrons or through bonds. That is known as electron displacement. And depending on the attacking reagent, this electron displacement can be of two types. It can be a permanent effect or it can be a temporary effect. If no attacking reagent is needed for the displacement of electron, then such effect is known as permanent effect. And if an attacking reagent is needed for electron displacement, then it is known as temporary effect. Basically, there are four different types of electron displacement reactions: inductive effect, resonance effect, hyperconjugation, and electromeric effect. So first, let's see what is inductive effect. Basically, in a covalent bond, what is a covalent bond? A covalent bond is a bond that is formed by sharing of electron. Okay, sharing of electron. Here, one atom, this atom A is sharing its electron with the other atom A. If the atoms contained or constituted in a covalent bond is the same atom, then the electronegativities are same for these atoms, and therefore the two electrons will remain at the center. And if we have A and B are connected through a covalent bond, here A and B are dissimilar atoms. In this case, the electron will be shifted towards the more electronegative atom, and if here B is more electronegative, then the electron will be shared towards B. So what is inductive effect? The polarization of a sigma bond due to the electron withdrawing or electron donating effect of adjacent groups of atoms is known as inductive effect. Now let's see the salient features of inductive effect and what is the reason for the cause of inductive effect. It's due to the electronegativity difference between the two atoms. So that is one point. And this inductive effect here, see here we have 1, 2, 3, 4. This is chlorobutane. Okay, chlorobutane. So we know that the chlorine atom is more electronegative, and so it pulls the electron of this bond towards itself, and thus a small negative charge is created on the chlorine atom, and since the electrons are moving towards the chlorine, a small positive charge is developed on this carbon, and this positive charge will cause the electron of this bond to move towards this atom, thereby creating another small positive charge over this atom. So this is transmitted. So we can say that inductive effect is transmitted through sigma bond. That is point number 2. And again, you can see here that here we have a positive charge, delta positive, and as the distance from this site is increasing, the effect is decreasing. That means the strength of this positive charge is decreasing. So we can say that the magnitude of inductive effect decreases with increase in distance. And this is the third point. And the fourth point is that it is a permanent effect. Why is it a permanent effect? Because for the inductive effect, no external reagent is needed. So it is a permanent effect, and it influences the chemical and physical properties of compounds. So these are the salient features of inductive effect. Now let's discuss the types of inductive effect. We have two types of inductive effect: minus I effect, that is negative inductive effect, and positive inductive effect or plus inductive effect. First, let's see what is negative inductive effect. So negative inductive effect is caused by the polarization due to electron withdrawing groups present in a molecule. Okay, so here X is an electron withdrawing group. So the X pulls the electron towards itself, thus a polarity is created in this molecule. So this is negative inductive effect, and the decreasing order of negative inductive effect follows cyanide. Sorry, not cyanide. First one is nitro group, then cyanide group, then carboxylic acid group, then fluorine, chlorine, bromine, iodine, then OCH3, and last CH3. This is the decreasing order of minus I effect seen for atoms or molecules. Now let's see what is positive inductive effect. Positive inductive effect is caused by the presence of an electron donating group in a particular molecule. Here Y is electron donating group, so it donates its electron to this carbon atom, thereby it has a net positive charge and this carbon is having a net negative charge, so that is positive inductive effect. And the positive inductive effect is shown by tertiary group. So tertiary group will have more plus side effect than secondary, which follows primary, and then it follows the CH3 group. Okay, so this is the decreasing order of decreasing order of positive inductive effect. Now let's see the applications of inductive effect in the case of acidities of carboxylic acids. So first let's see the effect of substituent on the acidity of carboxylic acid. So what is carboxylic acid? R C double bond O OH. This is the structure of carboxylic acid. So what do you mean by acidity? Acidity is the ability of a particular compound or molecule to lose H plus ion. So what happens if an H plus is lost from this carboxylic acid? We will get R C double bond O O minus. Okay, this H plus is lost, so O minus. So this is known as a carboxylate anion. Carboxylate anion. And this carboxylate anion can exhibit resonance effect. This negative charge can displace to this side, so this double bond will be shifted towards this oxygen. So we have this structure. Here the oxygen carries a negative charge and this oxygen is having a double bond. So this is the structure of carboxylate anion. So we know that wherever a resonance is possible, that structure will be stabilized, and therefore this reason carboxylate anion will be more stable when compared to the carboxylic acid. So carboxylic acid will try to donate its H plus ion and remain in the stable carboxylate anion, thus creating an acidity for the carboxylic acid. And if a electron withdrawing group is present, here, what will the electron withdrawing group do? That will electron withdrawing group will pull the electron pair towards itself, thereby weakening the OH bond, and therefore an electron withdrawing group will increase the acidity of carboxylic acid. And if a electron donating group is present, what happens? The electron donating group will donate electron towards this carbon, thereby strengthening the OH bond. So it will be difficult for the H plus to get removed from the side. So the electron donating group will decrease the acidity. Okay, now let's take an example, the relative acidic strength of chloroacetic acid and acetic acid. Okay, so this is a structure of chloroacetic acid, Cl, CH2, C double bond O, OH, and this is the structure of acetic acid. And we know that chlorine is a minus I group, isn't it? So it will withdraw electron. So it is an electron withdrawing group. So this chlorine will pull the electron from the side to itself, thereby weakening the OH bond. So the H plus can be removed easily. But in the case of acetic acid, it contains CH3 group, and CH3 group is an electron donating group. Electron donating group will enhance the electron towards the side, thereby strengthening the OH bond. So it will be difficult to break this OH bond, and therefore chloroacetic acid is a stronger acid when compared to that of acetic acid. Now let's discuss the acidities of different chloroacetic acids. So this is a trichloroacetic acid. So trichloroacetic acid has 3 chlorine atoms which are electron withdrawing. So it will definitely have acidity greater than that of dichloroacetic acid, which has only 2 chlorine atoms. And this dichloroacetic acid will have more acidity when compared to chloroacetic acid, which has only 1 electron withdrawing group, and this will definitely be more acidic when compared to acetic acid, which contains a plus side group, that is methyl group. So this is the acidity of acetic acid when compared to different substituted chloroacetic acids. And there is one more point over here, that is smaller the pKa value, greater will be the acidity. Okay, so this is about acidities of chloroacetic acid and acetic acid. Now we'll discuss the acidic strength of formic acid, acetic acid and propionic acid. Okay, so let's discuss the structure. Formic acid is HCOOH. Then acetic acid is CH3COOH, and propionic acid is CH3CH2COOH. So we know that this CH3 is a plus I group, and CH3CH2 is also a plus I group, but H, it doesn't have any plus I effect. Okay, so basically here formic acid will be more acidic, and when comparing the plus I effect of CH3 and CH3CH2, we know that this CH3 will be stronger. So acetic acid is the next stronger acid when compared to propionic acid, and this is the order of strength. And we can discuss the plus I effect over here as the CH3 group. Okay, CH3 shows more plus I, more plus I when compared to hydrogen, and it is less plus I when compared to the CH3CH2 group. So this is the order of plus I effect, and accordingly this will be the order of acidic strength. Now we'll discuss the relative acidic strength of fluoroacetic acid, chloroacetic acid and bromoacetic acid. So fluoroacetic acid is FCH2COOH, then chloro ClCH2COOH, then bromo BrCH2COOH. So here the fluorine, chlorine and bromine, they belong to the same group, that is they belong to the halogen family, that is group 17, and we know that the electronegativity order for fluorine, chlorine, bromine follow the order. Fluorine will be more electronegative when compared to chlorine, which is more electronegative when compared to bromine, and which is more electronegative when compared to iodine. That is, the electronegativity decreases down the group. So the more electronegative group will show more acidic character. Okay, so here fluoroacetic acid will be more acidic when compared to that of chlorine, which will be more compared to that of bromine. So order of acidity follows. Fluoroacetic acid is stronger acid when compared to chloro, which is more when compared to that of bromo, and which will be more acidic when compared to that of iodoacetic acid. Next we'll discuss about the relative acidic strength of 2-chloropropanoic acid and 3-chloropropanoic acid. So what is 2-chloropropanoic acid? The structure is Cl, CH2, CH2, COOH, and 3-propanoic acid means Cl, CH2, CH2, COOH. This is 1, 2, 3. 3-chloropropanoic acid and 1, 2. Okay. This is 2-chloropropanoic acid. Okay. So 2-chloropropanoic acid and 3-chloropropanoic acid. So which will be more acidic? Okay, we know that the effect of inductive effect decreases with distance, isn't it? So in this case the chlorine is present here, and in this case the chlorine is present here. Okay, so here the chlorine is more closer to the acidic group, so definitely inductive effect will be more when for the 2-chloropropanoic acid when compared to that of 3-chloropropanoic acid. So this is all about inductive effect. I hope you understood every point related to inductive effect. Thank you.